Welcome to the Allen Resources core video. My name is Fernando and I'm the Whitman Associate Professor of Finance at the M.J. Whitman School of Management at Syracuse University. And today we'll be talking about derivatives. I'm also a commodity trading advisor and founder of my own money management firm. And I'm telling you that just to make sure that you know, we'll be covering derivatives not only in an academic fashion, but in a real-world application fashion. Let's start by defining a derivative security. And I want you to realize that a derivative security, or the elements of derivative securities, are four. One, it is an agreement between two parties, and that is very important in any derivative. That is an agreement between two parties, sometimes called counterparties. This agreement is to transact something which we call the underlying asset, and that is a word that will be coming up very often in our treatment of derivatives. So remember, a derivative security is an agreement between two counterparties to transact something that we will call the underlying asset. When we'll be transacting this something or this underlying asset? At a future date. That's the third element of a derivative. And the fourth element is that what is the price that we'll be transacting this asset for? And that is the agreed upon price that has different names depending on which derivative we're talking about. Let's go through each of these elements individually. Remember, the first element is that a derivative security is an agreement between two parties. Who are these parties? Well, it could be you and a bank and a corporation, for example, in four markets or four currency markets, two banks, a utility company and a generating company, for example, in the case of electricity forwards. Now we're going to the second element of a derivative, the transacting something or the underlying security or the underlying asset. We can have agreements or derivative securities on shares of common stock, for example, like a stock option, crude oil, like futures on crude oil, electricity, like forward on electricity, an interest rate, like options on interest rates, a bond, like T-bond futures, or even we can have derivatives on another derivative. Now we're going to the third element of a derivative, which is the time where this transaction happens. Remember, at some time in the future we'll transact, okay, this underlying asset. The important thing here is that these agreements expire. In other words, they have an end. Usually at expiration, the agreement is settled with the transaction of the underlying. And finally, let's move on to the agreed upon price. Remember that we agreed to transact at a certain time this underlying asset at an agreed upon price. And this price has different names depending on the agreement that we're talking about. For example, if we're talking about a forward contract, this agreed upon price that we agreed to transact at is called the forward price. If we're talking about a futures contract, the agreed upon price is called the futures price. And if we're talking about an option contract, the agreed upon price that we've agreed upon transacting is called the exercise price. Now, let's understand why these agreements are called derivatives. That is a question that I get all the time. Why are they called derivatives? Simply because the value of these agreements derives from what? From the value of the underlying asset. For example, the value of an option on a stock depends on what? On the value of the shares of common stock that this agreement is based on. Let's now walk you through the types of derivatives that we're going to talk about. We're going to talk about four main types of derivative agreements: forward contracts, futures contracts, option contracts, and swap contracts. That are the major four types of derivative agreements out there. Most people ask me, what are derivatives for? What are they used for? What is their purpose? So we have to have that clear in our minds. The purposes of derivative markets are, the first one, and perhaps the most important one, is risk management. Derivative markets are markets for insurance. For example, all of you have to buy house or car insurance. without knowing that insurance or car insurance is actually an option, a put option for that matter. The second major function of derivative markets is price discovery. And you may ask yourselves, well, what is price discovery? Well, many times people don't know where to find the price for whatever they produced. In the case of farmers, for example, they look at futures markets or agricultural futures markets to figure out what is likely the price of wheat or corn will be in the future and how much they'll be getting paid for their harvest. So in this case, futures markets help them discover what prices they're likely to be paid in the future, and that's the price discovery function. And the third function is that derivative markets allow you to do certain transactions with the lowest cost possible. So remember, risk management or the insurance function is perhaps the most important, but price discovery is quite important too, and never forget about the least cost way of doing many transactions that would be extremely more expensive if you wanted them done in a different way. Now, most people see derivative contracts as very bad, actually, as reflected by popular press. But why is it that people think derivative markets and derivative agreements are bad? Let's look at the three main reasons why that may be so. These agreements tend to be more complex than plain vanilla stocks or bonds. Since they are slightly more complex, they're more difficult to understand for the layman. But the real reason why derivatives can be bad or can be dangerous is that very highly leveraged. Let's now define what high leverage is. And let me give you a definition of high leverage. High leverage means that relatively small price changes in the underlying asset price. And so remember that derivatives are agreements that are based on an underlying asset, okay? And I'm saying relatively small price changes in the underlying price can cause very large swings in the counterparty equity. So what I want to do is give you an example of this definition by using the heating oil futures contract. So let's move to that contract example. In the example, let me just tell you that one heating oil futures contract is written on 42,000 gallons of heating oil. So that's the underlying asset. The underlying asset is heating oil, and actually for a futures contract is 42,000 gallons of heating oil. Now, at a futures price of $1 a gallon, what do you think the value you control of that commodity is? Well, it will be 42,000 gallons times $1 per gallon, or 42,000 gallons. Now that we've calculated what we call notional value, let's move on to figuring out what high leverage means. Remember now, one contract controls $42,000 in the commodity. A 1 cent increase in the futures price represents how much in terms of dollars? Well, it represents 1 cent times 42,000 gallons equals $420. Okay? Now, how much is that as a percentage of the value of the whole contract? Well, $420 is only a 1%. Okay? 420 is 1% of $42,000. So what this means is that 1 cent increase in the price of heating oil represents a 1% change in the price of the underlying. Now, what we haven't defined yet is that where is leverage coming in? The important thing here is that to trade one heating oil futures contract, we need about $5,000. Okay? So in order to transact in one of these heating oil contracts, we need to deposit with our broker $5,000. Now it's time to realize where the high leverage comes in.